Okay, so in this lesson, we're going to learn how to graph linear equations. And first of all, let's consider this particular equation, x plus y equal 5. So notice that this equation has two variables. There's a variable x and a variable y. So I'm trying to find the solutions to this particular equation. So what values of x and what values of y, when I add them up, I'll get 5. Okay, so for example, if I use a t-table, with this particular problem, and if I let x be 0, let's say, so if my x coordinate is 0, let's find the y coordinate. So if the x coordinate is 0, wherever we see the variable x, I'll plug in 0. So basically I get 0 plus y equal 5. 0 plus y is y, so y equals 5. So that's my y value. And it kind of makes sense because if you look at the coordinates 0 for x and 5 for y, if I substitute these values back into here, I get 0 plus 5, and 0 plus 5 is 5, and 5 does equal 5. All right, so these are the solutions to that equation. So remember, a solution is, in this case, solutions, plural. Notice that this equation has two variables, so the solution would be what x and what y will make this equation a true statement. All right, so if I look at, let's say y this time, let's look at y. So let's say y this time is 2. So if y is 2, I get this. I get x plus 2 equal 5. And so to get x by itself, I'm going to have to subtract 2 from both sides. And then combine like terms, I get this is 0. So I get x equal 3. And so that's the value of x. So again, it makes sense because, remember, x is 3, y is 2, 3 plus 2 is 5. If I let x, let's do x this time. If I let x be, now remember here we let x be 0 first, and then here we let x be 2 first. So if x is, y be 2 first. So if x is, let's say, negative 2, I get negative 2 plus y, equal 5. And to get y by itself, I'm going to add 2 to both sides. Not subtract 2, you're going to add 2 because remember you're trying to get y by itself. So you need this to be a 0. So a negative 2 plus a positive 2 is 0. 0 plus y is y, and 5 plus 2 is 7. So I get my y value to be 7. And it kind of makes sense because remember you're adding your x and your y. According to this equation, you're adding your x and your y, and you want that to be 5. And it is a true statement that negative 2 plus 7 is 5. And so remember I substitute this first. So let's this time choose a value for y. Let's say y is negative 3. Let's see what happens. So if y is negative 3, I get x plus a negative 3, equal 5. Now keep in mind that x plus a negative 3, I'm going to make this expression right here easier to deal with. So x plus negative 3 means the same thing as x minus 3. All right, so just keep that in mind. So x plus a negative 3 is the same thing as x minus 3. And so if I get x by itself, right now I'm subtracting 3. The opposite is to add 3. So I'm going to add 3 to both sides. Combine like terms, negative 3 and 3 is 0. X and 0 is x, and so x is 8. So my x value is 8. All right, so when x was negative 3, I got my y value to be 8. And it does make sense that 8 and a negative 3 does equal 5. So those are solutions. So keep in mind that all these points here, all these points right here that I just found, those are solutions to that equation. And I can keep on going. So there's an infinite number of solutions. So there's an infinite number of solutions. As long as the x-coordinate and the y-coordinate satisfies this equation, that's a solution. All right, so there's an infinite number of solutions. Now, if I were to plot those points, in a coordinate plane, remember these are coordinate planes right here. So this is a coordinate plane. And remember, a coordinate plane has 4 quadrants. So you have your x-axis right here. So you remember your x-axis is your horizontal axis, and your y-axis is your vertical axis. And these two axes divide this coordinate plane into 4 quadrants. So remember, this is quadrant 1, this is quadrant 2 right here, this is quadrant 3, and this is quadrant 4. So just remember your quadrants. So quadrant 1, quadrant 2, quadrant 3, quadrant 4. So you go counterclockwise. 1, 2, 3, 4. And remember, the axes, your two axes, intersect at this point right here. That's called the origin. All right, so remember the origin. All right, so let's talk about graphing these points right here. So let's look at the point 0, 5. So you always start at the origin. So the origin right here, where the x-axis and the y-axis intersect, notice that when we look at the x-axis, this right here, let me go ahead and kind of make it a little bit better to where you can see it. All right, so if you look at this right here, to the right of the origin, remember we talked about the origin, to the right of the origin are positive numbers, to the left are negative numbers. When you go above the origin on the y-axis, those are positive. When you go below, those are negative. All right, so this is you can't see the negatives, but that's -1, -2, -3, and so on. All right, so you always, when plotting points, remember you always start at the origin. So let's plot the point 0, 5. So I'm plotting the point 0, 5. And remember, you always indicate a point with parentheses, so that's a point. So when x is 0, that means I'm going to stay at the origin. I don't move right or left. So you look at your x first. So x is 0, I stay there. If y is +5, that means I go up 5. 1, 2, 3, 4, 5. So there's the point right here. There's the point 0, 5. Okay? All right, let's look at the other one. So the other one was 3, 2. So let's plot the point 3, 2. So to plot the point 3, 2, I started the origin. Always start at the origin. Remember, you're plotting the point 3, 2. You start at the origin. Since the x-coordinate is positive, remember this is your x, this is your y. Since the x-coordinate is +3, I go to the right 3. All right, so don't put a dot there because you're all you've done so far was located where x is 3. So x is 3 here, but I want to plot this point. So I need to look for the point 3, 2. So since x is 3, I go to the right 3, and then y is 2, +2, I go up 2. So there's the point right here. That's the point 3, 2. This right here was the point 0, 5. All right, let's look at the other one. Let's look at the point -2, 7. So -2, 7. So I'm looking at -2, 7. So remember, your x-coordinate is -2, your y-coordinate is 7. Always start at the origin when plotting points. So here's my origin. Since x is -2, that means I go to the left 2 right here. Okay, that's not your point. You're just going to, all you've done at this point was just went to the left 2 units. So here's x -2 right here. So you went to the left 2 units. But y is +7, so I go up 7. 1, 2, 3, 4, 5, 6, 7. So there's the point. That's the point, -2, 7. And then remember, we looked at one more solution. So 8, -3. If you look at 8, -3, if you look at that, again, so that's your x-coordinate, that's your y-coordinate. So to plot that point, I start at the origin. I go to the right 8 units. X is positive, so you go to the right 8 units right here. And then y is -3, so I go down 3. 1, 2, 3. So notice it matches what this number is here, right here. So there's a point 8, -3. Now remember, these points are solutions. These points are solutions to this equation that we had earlier, right here. And we also noted there's an infinite number of solutions. So all I've done was just given 4 solutions, but there's an infinite. I want you to notice about these solutions here. So if you notice, these solutions look like they lie in the same line. So if I were to draw a line connecting those points right here, just like this, and don't forget to draw an arrow, that's the equation, that's the graph of this line. So the graph of this line, of the line x plus y equal 5, is this. So whenever you're graphing a line, you're graphing the solutions to this equation. So that's basically what you're doing. So any point on that line is a solution. Any point of the line is a solution. So if I were to let's say x be 8. I'm sorry, let's say 9. Let's say x was 9. All right, and let me go ahead and kind of decrease the size here. All right, so if x is, let's say, 9, and I go back to this equation right here. So 9 plus y equal 5. To get y by itself, I'm going to subtract 9. 9 minus 9 is 0, and so y equal -4. And if I go back, so I found another solution. So another solution to this equation is x is 4, y is x is 9, y is -4. And if I look at my graph that I just did, here's 9, -4 right here. So all these are solutions. So any point in that line is a solution to this equation. So in graphing an equation, a linear equation, see, these are linear equations, so those are lines. When graphing a linear equation, you're graphing the solutions. Any point that's not in that line is not a solution. Okay, so keep that in mind. So all these points right here are not solutions. Only these are solutions to this equation. Okay, now let's kind of summarize a little what we just talked about. Okay, so this equation right here, x plus y equal 5, that we just looked at, is called a linear equation in 2 variables. All right, so there are 2 variables. It's called a linear equation in 2 variables. It's called a linear equation. Now notice in the word linear is the word line. It's called a linear equation because when we graphed it, we had a line. We got a line. All right, so x plus y equal 5 is a linear equation in 2 variables, and the graph of every linear equation in 2 variables is a straight line. Okay, now let's look at the definition of a linear equation. So a linear equation in 2 variables is an equation that looks like this: ax plus by equal c. So notice you have 2 variables. There's a coefficient of x, there's a coefficient of y, and then your constant is on the other side. Okay, so it looks like this. All right, and so notice also that a, b, and c can be real numbers. A, b, and c can be real numbers. So any real numbers. It could be decimals, it could be fractions, it could be rational numbers, irrational numbers. Any real number, a, b, and c. In our case, though, we're going to be looking at nice numbers. So in this lesson, we're not going to be dealing with any decimals or any irrational numbers. Okay, we're going to have fractions, but you're not going to see any decimals here. And a and b cannot both be 0. One can be 0, the other one can't. You're going to see this as we go through this. All right, so notice whenever it's in that form where you have the variables on one side, the constant on the other, that's called standard form. So ax plus by equals c is called standard form. All right, now here's some examples of equations, of linear equations. So 3x plus y equal 2, negative 4x equal 5y, y equals 2/3 x minus 1, y equals 3. So all those are examples of linear equations. Notice, though, that this one here is the only one that's in standard form. Notice the variables on one side, constants on the other. The coefficient of x is 3, so a is 3. Coefficient of y is positive 1, so b is 1, and c is 2. These are all other forms of writing any linear equation, but this is the only one that's in standard form. Now, in the next lesson, you're going to see that this right here, this linear equation, that's in slope-intercept form. This is called slope-intercept form. Okay, slope-intercept form. This is the only one that's in this right here is the only one that's in standard form. All right, and these don't have any special names. All right, so this is slope-intercept form. This is standard form, and by the way, this right here is also in slope-intercept form as well. Whenever you get y by itself, you've written it in slope-intercept form, and that's going to be the next lesson. Okay. All right, so all these are written in different forms, but again, this is the only one that's in standard form. Whenever y is by itself, that's slope-intercept form, and that does mean something in the next lesson. Okay, so let's start graphing linear equations. So let's graph some linear equations. All right, graph linear equations. Now, keep in mind that to graph a linear equation, you need at least 2 points. Okay, you need it. To graph a linear equation, you need at least 2 points. Okay, so let's look at some examples. Here's the first one. Number 1, x minus y equal 3. X minus y equal 3. And in this lesson, to graph these linear equations, we're going to use a t-table. So let's use a t-table. T-table. And so I'm going to draw something like this. So a t-table looks like a t. This is the x-coordinate. This is the y-coordinate. All right, so let's suppose in this case that x is 2. So I'm letting x be 2. So I'm circling what I'm substituting into here. So x is 2. So if x is 2, I get this. 2 minus y equal 3. 2 minus y equal 3. Now, I've got to get y by itself. Now some of you can guess as to what y needs to be, but let's do this algebraically. So 2 minus y equal 3, so I gotta get y by itself. Now there are a couple ways you could do this. You could subtract 2 from both sides. So 2 minus 2 is 0, but be careful, you don't have y left, you have negative y. So this is negative y equal 1. I'm trying to solve for y. Now remember, negative y means this, means negative 1 times y. That's what that means. So the coefficient of y here is negative 1. Now remember, you're trying to get y by itself. So you need the coefficient of y to be a positive 1, not a negative 1. So since I need the coefficient of y to be a positive 1, right now I'm multiplying by negative 1. The opposite is to divide by negative 1. So you divide by the coefficient. Don't say divide by negative 1y. It's got to just be the coefficient. And so negative 1 divided by negative 1 is a positive 1. 1 times y is y. And so I get 1 divided by negative 1 is negative 1. So my y-coordinate is negative 1. And it makes sense because look, if I check this solution, I get x minus y equal 3. So let's see if this is true. So x is 2, subtract y is a negative 1, equal 3. And in a previous course, you saw that 2 subtract negative 1, you can always change subtraction to addition by taking the opposite. So this becomes 2 plus the opposite of a negative 1 is a positive 1, and that is 3. Okay, so let's look at another one. So this time, let's suppose that x is negative 2. X is negative 2. Let's see, I'm sorry, y is negative 2, excuse me. Y is negative 2. So I go here, and where we see the variable y, I'm going to plug in negative 2. So I get x subtract a negative 2 equal 3. So I got to solve for x. So x subtract negative 2 equals 3. Now remember what we just talked about. X subtract negative 2 means the same thing as, remember, always change subtraction to addition. Whenever you change subtraction to addition, you add the opposite. Add the opposite. Okay, so you learned that in the previous course. So this becomes x plus a positive 2 equals 3, and now you can get x by itself. So subtract 2 from both sides, and so I get x is 1. So my x value is 1. All right, so when x is 1 and y is negative 2, that's a solution to this equation. So remember, you're finding solutions. And you can check, let's check this. I'm not going to check all of them, but let's just check this one. You go back to the original equation, which was this. And where we see the variable x, you plug in 1. Where we see the variable y, you plug in negative 2. So I get 1 subtract a negative 2, and I want to see if that's going to equal 3. Well, remember, 1 subtract negative 2 means 1 plus 2, and that is 3. All right, now remember, to graph a line, we just need at least 2 points. So this would suffice, but I could have made a mistake in one of these points here. When I did all this work, I could have made a mistake. So let's do one more, because remember, we saw that when we graph a line, all of these solutions have to lie in the same line, so they have to be collinear. So my points have to be collinear. So let's do one more to make sure the points are collinear. I'm using the word collinear. All right, they have to be collinear. All right. So when let's pick a value for x. So if x is, let's say, 4, if x is, let's do negative 4 this time. If x is negative 4, I get negative 4 minus y equal 3. So I'm going to add 4 to both sides. And so 4 and negative 4 is 0, but remember, you get negative y. So negative y equals 7. 3 plus 4 is 7. But you got to get y by itself. So remember, this negative y means negative 1y. That's the coefficient of y is negative 1 equals 7. Then divide both sides by negative 1. I get negative 1 divided by negative 1 is 1. 1 times y is y. And so 7 divided by negative 1 is negative 7. So I get the point negative 4, negative 7. Now remember, the other thing you could have done here, if you wanted to, it's up to you. So remember, we had negative 4 minus y equal 3. I could have, if I wanted to, added y to both sides, just like this. Added y to both sides. And then negative y and y is 0. So I get negative 4 equals y plus 3. Remember, 3 plus y. 3 plus y is the same thing as y plus 3. And then to get y by itself, I subtract 3 from both sides. And so I get y equal a negative 4 and a negative 3 is a negative 7. And that's what we got here. I could have done the same thing here. When I went here, right here, I'm going to go ahead and show you. When I would have done that one, I had 2 minus y equal 3. If I wanted to, I could have added y to both sides, just like this. And then combine like terms. This is 0. Negative y and y is 0. So I get 2 equal, now remember, 3 plus y, that's what this says, 3 plus y. 3 plus y is the same thing as y plus 3. So I get y plus 3. Subtract 3 from both sides. 2 subtract 3 is a negative 1. 3 and a negative 3 is 0. So you get y is negative 1. And that's what we had here. Okay, so there are multiple ways to get the variable by itself. All right, but remember, you need at least 2 points, but always be careful, because if you just use 2 points, one of those coordinates could be incorrect. So just make sure you do 3 points just to be on the safe side. All right, so those points have to be collinear. Okay, so let's go ahead and plot those points. So we're going to plot the point 2, negative 1. So remember, you started the origin. Since my x coordinate is a positive 2, I go to the right 2. and then my y coordinate's -1, I go down 1. So there's the point, 2, -1. Now if it says label, remember that means is this. Don't just put a dot here. You got to say, you got to tell me what those coordinates are, and you name a point. You label a point using parentheses. So you need the parentheses 2, comma, -1. So there's the point, 2, comma, -1. Over here, 1, -2. So you start the origin. You go to the right 1, down 2. So there's the point right here. 1, -2. I'm labeling these. So that's what I mean by labeling. So that's what label means right here. And then the point -4, -7. So -4, I go to the left 4. Since y is -7, I go down 7. So that's here. So that's the point -4, -7. And then I just take a ruler and I draw the line. When you draw the line, you got to make sure that the line goes through all your points and then draw an arrow. Okay, make sure you draw the arrows. You have to have arrows. So remember there, that just means that this line keeps on going. Keeps on going up, keeps on going down, and there's an infinite number of points on that line. Okay, so that's the graph right here. This is the graph of x minus y equal 3. So this is a graph of x minus y equal 3. All right, let's look at another one. Okay, let's look at this line. Suppose we had y equal 6x. Okay, y equal 6x. All right, I'm going to use a t-table. Use a t-table. If it says use a t-table, use a t-table. In the next lesson, we talk about slope-intercept form. We're going to use slope and intercept in that case. But if it says use a t-table, make sure you're showing the t-table. All right, so if x is 0, where we see the variable x, we plug in 0. So I get y equals 6 times 0, and 6 times 0 is 0. So y is 0. It's always, when graphing lines, it's always a good idea to let x be 0. Let x be 0. If x is, let's say, 2, I get y equal 6 times 2, which is 12. Okay, so I get 2, 12. If x is 1, I get y equal 6 times 1, which is 6. All right, now you may say, all right, so I have my at least 2 points. So let's go ahead and graph this. So when I graph this, I get 0, 0, which is the origin. Remember, that's the origin. So 0, 0 is the origin. Remember, that's the origin right here. That's the origin. That's where the x and the y-axis intersect. So this is the point 0, 0 that I just plotted right here. Now notice 212 is outside of this plane, so I'm not going to use it. So let's look at 1, 6. So 1, 6, so I'm going to go to the right 1 and then up 6. So that's in quadrant 1. So there's the point, 1, 6. And I need one more point. So let's say -1. If x is -1, I get y equals 6 times a -1, which is a -6. So I get -1, -6. So -1, -6 is right here. So this is the point, -1, -6, which is in quadrant 3. And then use your ruler. Remember, all these points need to be collinear, so they have to lie on the same line, and they do. Extend the line through the points and draw your arrows. So there's the graph of this line. So this is the graph of the line, y equal 6x. Okay, let's look at another one. Suppose we had this. Suppose we had y equal 1/4 x. Y equals 1/4 x. Okay, now listen carefully to this. You see in this example here, y equals 6x, the coefficient of x was an integer, 6. Here the coefficient of x is not an integer, it's a fraction, so 1/4. What you want to do in using a t-table, using a t-table, because remember when you graph these, I want you to notice something. When we graph these points and we label these, notice all the x-coordinates and y-coordinates, all the x-coordinates and y-coordinates were integers. There were no decimals, there were no fractions. So it's easy, if all of these are integers, it's easy to plot the points. It's very easy to plot the points. So when graphing a line, if possible, you want to make sure that all these coordinates are integers. So here we have a coefficient that's a fraction. So when picking values of x, you're going to choose numbers that are divisible by this denominator right here. You're going to choose numbers divisible by 4. So use values of x that are divisible by 4. So that way you will get integers. You'll get integers as your x and y coordinates, just like these. You didn't have any fractions, you didn't have any decimals. So it's easy to plot the points. So we're going to use values of x that are divisible by 4, whatever this denominator is. So if that was a 6, you'd use 6. If that was a 3, you would say divisible by 3. Okay? Now, 0 is divisible by every non-zero number. So regardless of what this denominator is, use 0, because notice what happens. I get y equal 1/4 times 0, and 1/4 times 0 is 0. So I get the origin here. All right, let's pick a number for x. Remember, you want to use numbers that are divisible by 4. So what number is divisible by 4? Well, 0, 4, -4, 8, -8, and so on. So all these numbers are divisible by 4. Because that means that when I substitute 4 into here, notice what happens. Y equals 1/4 times 4. Well, 1/4 times 4, remember 4 right here is 4 over 1. So 1 times 4 is 4. 4 times 1 is 4. So that's just 1. 4 divided by 4 is 1. So notice I get an integer. The integer is 1. If x is -4, I get y equals 1/4 times a -4. Same idea. If you need to, write -4 as a fraction. And remember, when multiplying fractions, you multiply numerators and then multiply the denominators, or you can reduce first. It does not matter. So 1 times -4 is -4. 4 times 1 is 4. -4 divided by 4 is a -1. So notice I get the integer -1. If x is 8, I get y equals 1/4 times 8, which is the same thing as saying 1/4 times 8 over 1. I can reduce first. In other words, I can say 4 into 4 is 1, 4 into 8 is 2, and then multiply numerators and multiply the denominators. So 1 times 2 is 2, 1 times 1 is 1, so I get 2. Notice, but what the point I'm making is that all these y coordinates are integers. So the x coordinates are integers, my y coordinates are integers. Notice though, remember I said choose numbers for x that are divisible by 4. 0, 4, -4, 8, -8, and so on. Some students seem to want to say right away 2. Well, 2 is not divisible by 4. When I say a number that's divisible by 4, what I mean is this. 4 divided by 4 is 1 with a remainder of 0. 8 divided by 4 is 2. 4 into 8 is 2 with a remainder of 0. You get a remainder of 0. 2 is not divisible by 4. 2 is not divisible by 4 because notice when I substitute 2 into x here, I get this. I get y equals 1/4 times 2, and then this becomes 1/4 times 2 over 1. 1 times 2 is 2. 4 times 1 is 4. Reduce, you get 1/2. So you don't get a an integer for your y value. You get a fraction. All right, so when using numbers for x, you want to try and get these y coordinates to be integers. All right, so always know what we mean by divisible by 4. And so you see, if I said 4 into 2, 4 goes into 2 0 times. 0 times 4 is 0 with a remainder of 2. So you don't get a remainder of 0. You need, when we say divisibility, you need a remainder of 0. This is not a remainder of 0. Okay. So I'm going to plot those points. So let's go ahead and plot the points. Now I did a few points here. We just need 3 of them. So let's do 3 of them. So I have the origin right here. I have the point 4, 1. So I go to the right 4, up 1, negative 4, negative 1. I go to the left 4, down 1. Right here. And remember, if it says label, you label. So that means 4, 1. That means 0, 0. And that means right here, negative 4, negative 1. And so you graph your line, and notice that all these points lie in the same line. They're supposed to lie in the same line. If they all did not, then you did something wrong. So go back and figure out what you did wrong. So that's the line, y equals 1/4 x. All right, let's look at another one. All right, suppose we had this equation. All right, let's graph y equals negative 2x plus 3. Y equals negative 2x plus 3. Again, we're doing this by using a t-table. So if x is 0, I get y equals negative 2 times 0 plus 3. Negative 2 times 0 is 0. 0 plus 3 is 3. So I get my point 0, 3. If x is, let's say, 2, I get y equals negative 2 times 2 plus 3, which is negative 4 plus 3, which is negative 1. So my y value is negative 1. I need one more, so let's do a negative. So if x is negative 1, I get y equals negative 2 times negative 1 plus 3. Negative 2 times the negative 1 is a positive 2. 2 plus 3 is 5. So my y value is 5. All right, so I plot those points, and I got my line. So I get the point 0, 3. So remember, we started the origin. X is 0, I stay there. I stay at the origin. Y is 3, I go up 3. So there's the point 0, 3. 2, negative 1, I go to the right 2, down 1. So there's a point 2, negative 1. And then finally, negative 1, 5. So negative 1, I go to the left 1, and I go up 5 right here. So here's the point, negative 1, 5. And then I draw my line, and there's your graph. So that's the graph right here. Make sure you extend the line through the points and draw your arrows. You've got to draw your arrows. So that's the line, y equal negative 2x minus, plus 3. Negative 2x plus 3. Okay, now let's look at another one. Suppose we had this. Let's graph y equals 1/3 x plus 2. 1/3 x plus 2. Okay, so again, notice the coefficient of x is a fraction. So let's think about what we talked about earlier. So when choosing values for x, we're going to choose numbers that are divisible by 3 this time. So like 0, always use 0. 3, negative 3, and so on. 6, negative 6. 9, negative 9, and so on. All right, but we don't need all of this. We just need at least 2 points. Okay, so if y is 0, if x is 0, I get y equals 1/3 times 0 plus 2. 1/3 times 0 is 0. 0 plus 2 is 2. So y is 2. If x is 3, I get y equals 1/3 times 3 plus 2. 1/3 of 3, remember that means 1/3 times 3 over 1 plus 2. So this right here means 3 divided by 3, which is 1. So it becomes 1 plus 2. So y is 3. If y is negative 3, if x is negative 3, excuse me. If x is negative 3, I get y equals 1/3 times negative 3 plus 2. So we got to figure out what 1/3 of negative 3 is. So what is 1/3 times negative 3? So remember, 1/3 times negative 3 is negative 3 over 1. That means 1 times negative 3 is negative 3. 3 times 1 is 3. And negative 3 divided by positive 3 is a negative 1. So this right here is negative 1, though. So that's negative 1 plus 2. And negative 1 plus 2 is a positive 1. All right, so I plot those points, and I draw my line. I plot those points, and I draw the line. So I get this. So 0, 2, I start at the origin. X is 0, I stay there. Y is a positive 2, I go up 2. 3, 3, so I start at the origin, remember. So you go to the right 3. X is positive 3, Y is positive 3. So I get this point. Negative 3, 1, I go to the left 3, up 1. So I get this point. And notice that these lines are collinear. They lie on the same line. So you draw your line, draw your arrows, and that's the line y equals 1/3 x plus 2. Okay? All right, let's look at another one. All right, suppose we had this one. Suppose we had this equation. So we had this equation. Y equals negative 2/5 x minus 1. Negative 2/5 x minus 1. Again, we're using a t-table. We're using a t-table. So always use 0 for x. So if x is 0, I get y equals negative 2/5 x minus 1. So wherever we see the value x, I plug in 0. So I get y equals negative 2/5 times 0 minus 1. Now remember, negative 2/5 times 0 is 0. 0 subtract 1 is a negative 1. So my y value is negative 1. Now remember, the coefficient of x is a fraction, so always use numbers that are divisible by this denominator. So 5. So like 5, negative 5, 10, negative 10, 15, negative 15, and so on. By using these numbers, that's going to make sure that these right here are going to be integers. All right, so let's do 5. So if x is 5, I get y equals negative 2/5 times 5 minus 1. So remember, you got to do the multiplication first. So multiplication first before subtraction. So let's figure out what negative 2/5 times 5 is. So negative 2/5 times 5 over 1. So negative 2 times 5 is negative 10. 5 times 1 is 5, and negative 10 divided by 5 is a negative 2. Now remember, the other way you could have done that is to reduce first. 5 into 5 is 1, 5 into 5 is 1, negative 2 times 1 is negative 2, 1 times 1 is 1, so you get negative 2. Okay? So you can multiply first and then reduce, or you can reduce first and then multiply. Okay, so that right here, though, remember, all we've done was found this to be right here to be negative 2. So I get negative 2 subtract 1, and negative 2 subtract 1 means negative 2 plus a negative 1, which is a negative 3. So y is negative 3. If x is negative 5, I get this. I get y equals negative 2/5 times negative 5 minus 1. So again, let's figure out what this part is right here. So negative 2/5 times a negative 5 over 1. Let's reduce. So 5 into 5 is 1. 5 and negative 5 is negative 1. So I get negative 2 times a negative 1, which is a positive 2. All right, so let's plot those points, those 3 points. They should be collinear. And then I draw my line. So 0, negative 1. I start at the origin. Since x is 0, I stay there. Since y is negative 1, I go down 1, right here. 5, negative 3. I start at the origin, go to the right 5, and then down 3. 1, 2, 3. So there's the point. So that's the point 5, negative 3. So I just labeled that point. Negative 5, 2. So I go to the left 5, and then up 2. Since y is positive 2, I go up 2. So there's the point, negative 5, 2. And so I draw my line, and notice that when I draw my line, they're not collinear. So see, they're not collinear. Something's wrong. So let's see. Let's see where the error could have been. Let's go back. So this one's correct. Y is -1. When over here, that's correct. 5, -3. And then, oops, okay, so here, remember how I said right here, make sure when you do this, you've got to go back here? Well, I made an error here. So here's the error. So it's very easy to make. So this is 2. 2 subtract 1. See, that's 2 right here. So I made a mistake here. So you see how you can easily, why you really need 3 points? All right. So if x is 2, if x is -5, this product is 2. But remember, you're subtracting 1. So 2 subtract 1 is 1. So y is 1. So that should be 1 right here. So let's put the point -5, 1. So -5, 1, -5, 1 is here. All right, so it's not this one. So that's -5, 1, and now it should be collinear. All right, and so notice that now the points lie on the same line. So again, notice it's very easy if you're not careful to make an error, but that's why we choose 3 points, so that way you can verify that those points do lie on the same line. Okay, so that was the graph of y equals -2/5 x minus 1. All right, let's look at another one. Suppose we had this. Suppose we had y equal 2. Y equal 2. Now, I want you to notice that in all the equations that we've done, notice that this equation, there's an x and a y, so that's a linear equation in 2 variables. That's a linear equation in 2 variables. This right here, though, is a linear equation in 1 variable. So let's talk about how to graph something like this, a linear equation in 1 variable. Now, whenever you see the x is not there, the x is gone, so the x is not there. So we're still going to use the t-table, and I want you to notice something. What this means. This means that y is always going to be equal to a 2. That's what that means. Y is always 2. So this column right here, see that y column? That's going to be 2 all the way down. That's what that says. Y has to be 2. Okay, y has to be 2. And no matter what x is, so if x is 0, y is 2. If x is -1, y is 2. If x is 3, y is 2, and so on. So it's when you have just one variable, that's the approach you want to take. So y is 2. That means that my y column is all going to be 2 no matter what x is. And I want you to notice what kind of graph you get. That's going to be important. And you probably remember this from last semester, but that's going to be important. So when I look at the graph and I plot those points, 0, 2, I start the origin, x is 0. I go down 2, I go up 2, that's this. -1, 2, I go to the left 1, up 2, that's this. I go to the right 3, up 2, that's this. Notice that those points, they lie in the same line, but this line that I'm about to graph, this line right here that I've graphed, that's a horizontal line. So this is the line y equal 2. So remember, and you may remember this from a previous course, that y equal a number is a horizontal line. That's a horizontal line. Y equal a number. So y equal a number is a horizontal line, and notice that it crossed the y-axis at this number 2. So you see right here, it crossed the y-axis at 2. So all these y values, and it kind of makes sense because if you look at all these y values is 2. So remember, this was 3, 2, this was 0, 2, this was -1, 2. So notice all these y values is 2. Okay? All right, let's look at this then. So we looked at y equal 2. Let's look at x equal 3. Let's graph that for x equal 3. So notice this is a linear equation in 1 variable. There aren't 2 variables. So just like our discussion here, this means that x has to be always equal to, oops, that's y. x has to be equal to 3. All the way down, that has to be 3. Just like right here, y had to be 2. Here that says x has to be 3. No matter what y is. No matter what y is. So x has to be 3. Has to be 3 no matter what y is. Okay, so if I plot those points this time, 3, 0, let's see what we get. So 3, 0, I start the origin, I go to the right 3. Since y is 0, I stay there. So here's the point, 3, 0. 3, negative 1, I go to the right 3, down 1. There's the point, 3, negative 1. 3, 2, I go to the right 3, up 2. There's the point, 3, 2. And notice that this time, my points lie on a vertical line. So this is a vertical line. So that's the equation x equal, in this case, 3. X equal 3. So notice that from a previous course, you may remember that when you have x equal a number and there's no y, when x equal a number, that's a vertical line. That's a vertical line. So y equal a number is a horizontal line. X equal a number is a vertical line. That's a vertical line. And it kind of makes sense because if you look at all these points that I plotted, if I label these, that was 3, 2. That was, I'm sorry, that was right here, that was 3, 2. That was 3, 0. And that was 3, negative 1. Negative 1. So notice that all these x coordinates are 3's. So no matter where I am on this line, my x coordinate is 3. Okay? All right. Now, let's look at this one. Suppose I had y plus 3x equal 2. Y plus 3x equal 2. All right, the way I would do this one is I would just go ahead and get y by itself. That's the way I would do that one. So get y by itself. So to get y by itself, because if you look at pretty much all these problems that we've done, except for the x equal a number, but all the problems that we've done, we had y was by itself. So just get y by itself. So to get y by itself over here, I'm going to subtract 3x on both sides. And so I combine like terms, that's 0, so I get y equal. And let's put the x term first. So that's y equals negative 3x plus 2. So negative 3x plus 2. All right, so we use the t-table now. Let's use the t-table. And so if x is 0, I get y equals negative 3 times 0 plus 2. Multiplication first before addition, order of operations. So that's 0 plus 2, which is 2. So y is 2. If x is, let's say, 1, I get y equals negative 3 times 1 plus 2. Negative 3 times 1 is negative 3. Negative 3 plus 2 is a negative 1. If x is, let's say, negative 2, I get y equals negative 3 times negative 2 plus 2. So wherever you see the value, the variable x, you're going to plug in negative 2. So I get negative 3 times negative 2 plus 2. Order of operation, you do multiplication before addition. So when I multiply, I get positive 6. 6 plus 2 is 8. So y is 8. And if I plot those 3 points, I get this. I get 0, 2 is here. Let's plot the point 1, negative 1. So I go to the right 1, down 1. And we're also the origin. Negative 2, 8. I go to the left 2, up 8. So that's here. And then I draw my line. So when I draw my line, I get something that looks like this. And so there's the line. Y plus 3x equal 2. And you could also said y equals negative 3x plus 2. Same thing. All right, either one's fine. Okay, and then let's look at this one now. Suppose we had this. Suppose we had 2y equals negative 3x plus 10. 2y equals negative 3x plus 10. Again, what you want to do here, just like you did over here, you want to get y by itself. It makes it a lot easier. How it's easy to find the points just by getting the variable y by itself. So this is the same thing here. Now be careful though. See here, this one was easy because the coefficient of y was 1. Here, the coefficient of y is not 1, it's 2. So right now, multiplying y by 2, the opposite of multiplication is division. So when I do this, you got to be careful. Look what I'm doing. Remember, what you do to one side, you do to the other. So if I divide this by 2, I've got to divide this by 2. So divide both sides by 2. That's how it looks. And then I'm going to write this right here as two separate fractions. Because remember, what you're doing here is you're saying this term has to be divided by 2. And this has to be divided by 2. That's what you're saying. All right, so every term had to be divided by 2. And now let's reduce. 2 divided by 2 is 1, so I get y equal, I can't reduce this, so that's negative 3 halves x, and then 10 divided by 2 is 5. All right, and now let's use the t-table. Again, just like we had our discussion earlier, we're going to choose numbers that are divisible by 2. Since this is a fraction, the coefficient of x is a fraction, choose numbers divisible by 2. So if x is 0, I get y equals negative 3 halves times 0 plus 5. If I multiply first, remember order of operations, you have to multiply first before add. This is 0. 0 plus 5 is 5. If x is, let's say, 2, choose numbers divisible by 2. If x is 2, I get y equals negative 3 halves times 2 plus 5. Negative 3 halves times 2, if you think about it, reduce first, I get this to be negative 3. So I get negative 3 plus 5. Don't forget, don't say that's negative 3. Remember, all you found was what this was, what I've circled. Negative 3 plus 5 is 2. I get y to be 2. And let's do one more. Let's say 4, if x is 4. If x is 4, remember you want to choose numbers divisible by 2. So if x is 4, this time I get y equals negative 3 halves times 4 plus 5. Okay? We got to figure out what this product is. Negative 3 halves times 4. So I'm going to go here. Negative 3 halves times 4. Let's reduce first. 2 and 2 is 1. 2 and 4 is 2. Negative 3 times 2 is a negative 6. Okay, so that's negative 6 right here. So that's negative 6, and then negative 6 plus 5 is negative 1. So y is negative 1. All right, so I'll plot those points. And so I get 0, 5, which is on the y-axis right here. That's 0, 5. I get 2, 2, which is in quadrant 1. There's 2, 2. And I get 4, negative 1, which is in quadrant 4. But notice, and remember, I'm labeling the points. That's labeling. And notice that when I draw my line, they all lie on the same line. All right, and there's the equation. This is the equation of this line is 2y equals negative 3x plus 10. Or you could have said, remember we got y by itself right here? You could have said this instead. So you could have said that's y equals negative 3 halves x plus 5. Okay? But regardless, that's the equation, or that's the graph, rather. That's the graph of this equation right here. Okay? All right, so this was, the lesson here was on graphing linear equations. Notice that, though, almost all of our equations had two variables in it, except these two right here. So y equal a number is a horizontal line. Remember how we did this. And then x equal a number is a vertical line. All the others, and that's going to be important in the next lesson, notice that all the other lines were not horizontal and they were not vertical. So notice that as we go from left to right, this line fell. This line fell. Here, this line is rising as you go from left to right, this line is rising. We'll talk about what that means. Here, as you go from left to right, this line is falling. So there are two variables involved, and there are two variables involved just like this. It's either going to rise or it's going to fall. If there's only one variable involved, like this, y equal number, then it's going to be horizontal. If it's x equal number, then it will be vertical. Okay? All right, so that takes care of this lesson.